The PE guy here. This is going to be the first video in a series of videos on the Power PE exam. My goal with these videos is to make a comprehensive review for the Power PE exam. I plan to have different videos on different topics that are on the PE that you need to know to do well on the PE. If you guys have recommendations for videos that you'd like to see, put that in the comments, and I'll try to make videos. So in this video, we're just going to go through the exam format and some tips on studying. So the exam is an 8-hour open book exam. There's 40 questions. There's two sessions. The morning session has 40 questions and it's 4 hours, and the afternoon session has 40 questions and it's 4 hours. I found that the morning session, the afternoon session, the questions were about the same difficulty level, so I didn't really find a big difference in the difficulty level of questions. So one thing about the exam is which calculators you're allowed to use. The NCEES website will tell you the exact calculators that are allowed, but a few calculators that I know are allowed are the Casio FX115, the HP33S and 35S, and the TI-30X and the TI-36X. I personally use the FX115ES, the Casio, and I found it to be pretty good. The most important thing for the Power PE is being able to do complex arithmetic on your calculator, because you're going to need to be able to convert between rectangular and polar and do addition and division and multiplication. So it's important to get a calculator that you can do that with. So just some study tips. I would recommend 200 hours. That's what I found on most places online. That 200 hours is the amount that you should study. I studied for about a year off and on the weekends. I usually studied in the library. I find that a quiet area where you're kind of by yourself is the best, because you don't get distracted. And I used to go on Saturdays and Sundays for between 4 and 8 hours to study, so that worked for me. One thing while you're studying is to make equation sheets. I would try to make my own equation sheets. You can always, borrow equation sheets from somebody else that has already taken the exam, but I found that making your own equation sheets is the best, because first, since you're making them, you know exactly where everything is, and while you make the equations, you get familiar with all the equations. So that's another important thing, that you get that familiarity with the equations and you know which ones to use in which situations. Another important thing while you're studying and doing practice problems is to use the calculator that you're going to use on the exam. So don't use a TI-89 while you're doing your practice problems, because that's not going to help you. You won't be able to use a TI-89 during the exam. So use the calculator that you can use during the exam. Another thing is there's a few I'll call them like human performance type things on the exam. So when you look at a question, the first thing I would do is I would check whether the question was 3-phase or single phase. And what I would do on the exam on a question is, if it was a 3-phase problem, I would just mark it on the question. It's 3-phase, or I would write single phase. And that just helped me to remind me that this is a 3-phase question. Don't use a single phase equation on it, right? And other things I used to I would like underline. If it was if the line voltage was given, I would underline that so I can just remember that I'm given a line voltage. Or if I'm given a phase voltage, I would underline that. Or if it was a delta or a y, I would flag that, just to remember, so I don't confuse myself, or I don't accidentally use a phase voltage where I should have used a line voltage. Another thing is per unit and ohms. Sometimes you're going to get values, parameters like transformer impedance or something, in per unit, and sometimes you'll get it in ohms. And sometimes in the same problem, you'll get one parameter in per unit and one parameter in ohms. So you got to be careful that you don't use an ohm value when everything else is in per unit and you're using an ohm value. You're going to get the wrong answer. So you got to make sure that you're careful about that. Another thing is units, particularly when you're talking like a rating of a transformer and rating of a and the voltage rating of that transformer. So your transformer rating might be given in MVA, and your transformer voltage is going to be in kV. So you can't just do 100 divided by 4. Say if you had a 100 kVA transformer, that's 4 kV. You couldn't just do 100 over 4, right? Because it's 100 MVA, so you have to account for that extra order of magnitude. So the way I did it is whenever I did a problem, I would write 100 e to the 6 in my calculator, or 4 e to the 3. So I'd make sure I included the magnitude in there, so I can make sure that the answer I got was correct. So you don't have to do that. You could do something else, but you got to make sure that you account for the units. Reference materials. One tip for reference materials is I would look for the previous editions of books I was looking at. So if I found a book and that book is currently on the 4th edition, I would go out and look for the 2nd edition book. So you can find them on Amazon. Amazon sells the old editions. So if the 4th edition book is like $200, you might be able to find a 2nd edition for $10, $20. So that's a good way to save money on reference books. And the material doesn't change all that much between the editions, especially for the purposes of the PE exam, where you really need it as a reference. It's not like a textbook for school or something. Some books that I found to be useful. I bought the PPI Power Reference Manual. Now this manual is very expensive, but it's very comprehensive. It has a lot of equations in it. It has a lot of different topics in it. So if you get stuck on something you don't know, you get some question, you don't know anything about it, well, the PPI Power Reference Manual might have something in there, and you can still get that question right just by having the manual. So that's why I got it, but it was very expensive. I'm not sure if it was worth the money or not, but I got it and I did well. I passed the exam, so it worked for me. A book on power systems. There's a book called The Elements of Power System Analysis by Stevenson. This is a pretty great book on power systems. It has a lot of different things. So it's got load flow in there. It's got per unit. It's got symmetrical and asymmetrical faults. It has symmetrical components. So it's pretty comprehensive in that regard. So I would definitely get that book without question. A good book on rotating machinery that I found was Electric Machinery by Fitzgerald. And that's a pretty good book on machines, so like motors and generators. And then another book that I got was on protective reeling. Now, protective reeling isn't all that big of a deal on the exam, but you never know. You might get a question on the exam about protective reeling, and if you have the right reference material, you might be able to get it right. The one I used was called Protective Reeling: Principles and Applications by Blackburn. And I'm sure there's other books out there, but that's the one that I found was good. And then the last thing I want to talk about is the NCEES practice exam. You can buy the practice exam online for about $30 from the NCEES website, and this is actually an old PE exam, so I would definitely get it because it's the closest you're going to get to actual exam questions. But one caveat is that I would wait until you're ready. You feel like you're prepared for the exam, you're ready to take it, and then I would take this practice exam. Don't look at it first. I would look at it at the very end, and that's really just to check that you're prepared. Because if you look at it first, then you're going to lose the value of the difficulty level of the questions. So I would definitely look at that at the very end. Okay, so now we're going to go through the actual syllabus of the exam. So let's take a look here. So the first section, general power engineering. Measurement and instrumentation. I didn't really look at this section all that much. The instrument transformers, that's important for protective relaying. So knowing CT ratios and PT ratios, that's important for the protective relaying later. So that's a good topic to learn a little bit about. It's not all that complicated anyway. Watt meters and volt metering, I didn't really look at this that much. And it seems like the exam has gotten away from asking questions on the watt meters. It's in the last several years, so I just completely skipped it. Insulation testing and ground resistance testing, I didn't really look at that either that much. This section, special applications. These are some topics that are not particularly difficult, and if you do a little bit of research into them, you can figure out how to solve these problems and get easy points on the exam. So lightning and surge protection, I didn't really look into that much, but reliability, engineering economics, demand, and energy management calculations, those topics are not that difficult. I'll probably try to do some videos on them. Illumination engineering, there's usually a question on illumination engineering. And it's kind of a difficult. I found that it would have taken me a lot of time to learn it because I knew absolutely nothing about it, so I didn't really focus on it that much. Codes and standards. This is kind of a big. This is kind of important, especially the NEC. So you need to make sure that the version of the NEC that you bring to the exam is the same one that they're going to test you to. So, like for example, this syllabus is for the April 2015 exam. And you can see they tell you that the 2014 NEC is what they're going to use. So you should just check and make sure you have the right version of the NEC. They'll ask you questions where they'll kind of try to mix and match a circuit analysis question and an NEC question, or something else like that. So it's important to know the NEC. One thing I did is I tried to flag the sections of the NEC that are important, and I'll do videos on that and tell you which tables are important and all the specifics. But that's it's important to know the section. There's a few sections of the NEC that you have to know well, so you should know those sections. The National Electric Safety Code. There'll be I found that it's not a big deal on the exam, but if you have that reference, then you'll be able to answer the question. You'll be able to answer a question on the National Electric Safety Code, and it won't be that difficult for you. But you have to have the reference. So I would definitely bring it along. There's another standard called 70E. It goes along with the NEC. It's electrical. It's another one on electrical safety. So I would definitely bring that along as well. So definitely bring along the NEC, the NESC, and NFPA 70E. Okay, the next section is circuit analysis. So this is kind of the real basics of power systems. So you really need to know this section well, particularly three-phase circuit analysis, per unit analysis, and phasor diagrams. You're going to use this in the other sections. You're going to, if you want to do other problems, you're going to have to know these things. Specifically per unit analysis, there's a lot of problems where they're going to give you values in per unit. So you need to know how to do per unit. That's important. And I'll try to do a follow-on video about per unit. Three-phase circuit analysis, that's just the basics of power systems. Symmetrical components, there'll be a few questions on it. And if you know the basics, you can figure them out. They won't give you, I don't think you're going to see terribly complex questions on symmetrical analysis and asymmetric faults, but there might be some more basic questions. So if you know a little bit about it, you probably know enough to get through the exam. Now, devices and power electronic circuits. I personally don't have a lot of background in this subject, so I didn't focus on this. I spent my time elsewhere. So, but if you have background in it, you might want to brush up, and because you can answer those questions, get some points. Rotating machinery, electromagnetic devices. So this is your motors and generators and equivalent circuits, speed torque characteristics. This is another important thing that you gotta know how to do. And then on electromagnetic devices, transformers, very important. And they might have questions on transformer testing, open circuit tests, short circuit tests. So we'll do some videos on that. And then transmission distribution. So System analysis, voltage drop and voltage regulation. Those are pretty easy. I mean, this is a pretty easy topic. Voltage regulation, you just kind of have to know the equations and how to use the equations. Voltage drop is kind of similar. We'll do some problems with voltage drop. You might need to use the NEC table to do a voltage drop problem. So that's kind of where, this is in the transmission distribution section, but you still need to know the NEC stuff to figure out how to solve the problem. Power factor correction, voltage support. This is, if you have some load at some power factor and you want to improve the power factor a little bit closer to 1, then you might want to add a capacitor. And how big does that capacitor have to be? That's what you're going to calculate in such a problem. So we'll do something about that. And then fault current analysis. So you have you have asymmetric faults and you have symmetrical faults. Most of what you're going to see is symmetrical faults, because asymmetrical fault it's so complicated. It'll take you so much time to try to solve something like that. I wouldn't anticipate something very complicated on asymmetrical faults, but you should still know some of the basics on how to set a problem up. And then for symmetrical faults, there's a method called the MVA method. Now this method is for doing symmetrical faults, and you can do a symmetrical fault very quickly and easily using this MVA method. Now if you do circuit analysis to try to solve the problem, it'll take you a while. But if you use the MVA method, it's real quick and easy. So that's definitely something to look into. And I'll try to do a video on how you solve a symmetrical fault using the MVA method. And then power system performance, power flow. There's some that power elements of power system analysis book is actually pretty good for power flow. If you have a question on power flow, you could probably look in that book and find the answer. And then load sharing, parallel generators or transformers. There's some pretty simple equations that you can use to solve parallel transformer problems. That's an easy question that you might get asked. So we'll go look at that. So protection. So a lot of the protection stuff, you can find some of this protection stuff in the NEC. So we'll look at those sections of the NEC and try to figure out how do you size a fuse or a breaker, and and thermal overloads and stuff like that. And then protective relaying. There's all sorts of different kinds of relays, and there's different applications for those. So we'll look at some relays and how you figure out what the sizing of the relays is. Coordination. We'll probably look at some coordination plots. How to read a coordination plot is probably important if you don't know how to do that. So that's all I wanted to look at for this first video. Thanks. See you next time.